Hey everyone, next up we have Nathan from Figment. He'll be doing a talk on measuring what matters, how protocol architecture impacts validator performance. And I'll let him take it from here.
Hello everyone, well, it's a pleasure to chat. Again, my name is Nathan Workman and I'm with Figment Inc. We do back-end architecture and infrastructure for numerous blockchain networks that are operating on proof of stake. And I'm part of the protocol research team, essentially. We call it just the protocol team. But one of the things that we look at is how networks operate and how to optimize performance on networks, not only from a validator perspective, but also from a token strategy perspective, and how can we be good participants in these ecosystems. And one of the issues that comes up fairly frequently for us, which I'm excited to talk about today, is what constitutes a good validator in the first place? How do you know that your performance is actually good? How do you know that you're working with somebody who's operating in an optimal way or in a suboptimal way? And one of the threshold issues that we run into here is, everybody obsesses about uptime. Uptime is more of a Web 2 issue in many respects. And one of the things we want to be careful about is taking a traditional Web 2 framework in terms of how to measure server performance or network performance or network operation performance, and then translate that into Web 3, where it might be relevant in some respects, but it might not be completely transferable. So we'll talk about some of those attributes today and maybe how to create more of a Web 3 framework in terms of how to measure these types of issues. So first off, what does a validator really do, right? Validators on proof of stake networks are an entity that will help to basically manage how consensus is done on that network. In some other networks, they also perform some other functions, like live peer, for instance. They can do other functions as well. But on most networks, again, it's the primary party who's responsible for managing consensus of the network. So when you have a delegated proof of stake network, parties can delegate tokens to that validator and share in the rewards that validator is earning by performing consensus. The rewards that are earned are largely transactional in nature, things like share of fees associated with transactions like exist on Ethereum. You can earn rewards for proposing blocks. You can earn rewards for attesting blocks. On other networks, there's inflationary rewards that are pretty much the primary way that they will compensate people that participate with consensus. There's not as much transactional rewards. And then in some, it's just based on luck. Cardano and a couple of other networks, there's an element of luck involved in how much rewards will be paid to a validator. So by delegating to a validator or by using a validation service company to operate a white labeled validator, you're able to participate in that consensus and share in those rewards. So one of the traditional metrics for any type of operator of any service on the web, if you're buying web hosting or if you're using hosting for other applications, is uptime. How often are you available? Are you communicating to other servers? Is there any type of lag? Is there a configuration issue or something else that would possibly challenge your ability to operate to whatever SLA or whatever other spec has been established for you to have connectivity to other parts of the internet? That translates somewhat well to validator performance, because obviously if you're not online at all, you're not going to be able to participate within consensus. But network architecture and network design has some tokenomics that may not make it as critical, or basically once you've reached a certain amount of uptime, that's enough. And then there's other measures of operating as a validator that are a little bit more performant. So first off, let's take a look at just uptime itself. Networks don't define uptime necessarily the same way that you would in a Web 2 configuration. Mostly for Web 2 purposes, uptime is going to be considered how much are you online as a total percentage of time that you could have been online. Now, obviously, if you're taking yourself offline for purposes of doing an upgrade or for some other type of purpose intentionally, usually that's not factored into your total downtime. But if you're down because of a network latency issue or you're down because of a configuration issue, how much time were you down compared to how much time were you up? Divide the two numbers together, and that gives you your uptime percentage. Now, on some networks, they will calculate downtime in a different way. And then if you're getting downtime penalties, or if you're getting slashing penalties that are related to downtime, it's important to understand that how much you are connected to the internet in general. So if you're running web validator architecture on bare metal, or you're running it through AWS or Google or whatever platform that you're running it performing computing and operations on, that might have tremendous connectivity with the internet itself. Now, just because again you have that network latency to the pipe doesn't necessarily mean that you have connectivity to the network. There are other layers involved. One is the client configuration of the software that the validator is running. Is that compatible with the network? Just because you're online doesn't necessarily mean that you're communicating to the network itself. So there is usually a component of validator availability on a network. So to give an example of this, on Solana, they have a validator availability metric, which is basically, can you participate? Are you available to be able to connect to other nodes? Are you available to be able to utilize the network in order to connect? The second is when you had the opportunity to post a block, were you configured correctly to actually post? So they call that a block skip rate. You have other networks like Ethereum that operate on more of a validator effectiveness model. What that's saying is, hey, when we don't take a look necessarily at are you connected to the network and measure that as a metric. What we take a look at is you're going to be called upon to perform services, and you might be called upon to propose a block. You might be called upon to attest a block, and this is going to be frequent enough that if you are connected, you'll participate in these things, and if you are not connected, you will not participate in these things. Or if you are validating a block, how quickly did you do it? If you have extremely high network latency, then you're going to be able to attest it very quickly, and by attesting it quicker, you can earn more rewards. By testing slower, you'll eventually earn less rewards until you just miss the attestation altogether. So again, it's uptime means different things for different networks, I think is the major takeaway there. Just because, again, you have good connectivity with an internet provider, and they can show, hey, AWS is showing that we are 99.997% up. Great. The hardware and the infrastructure might have connectivity, but that doesn't necessarily translate to network connectivity, nor does it necessarily constitute network uptime. Also, in terms of total network uptime, especially for Cosmos-based networks, you don't have to be online all the time in order for your performance to be affected or not affected. So Cosmos is a good example of this. The way that they measure uptime is during a period of blocks, how online were you? And unless you miss a certain percentage of blocks on the network, you're not going to have a downtime penalty. So if you take a look at most Cosmos-based networks, or Avalanche is a good example of this as well, practically all the nodes are having responsiveness in the 99.97% range, regardless of who operates it. Just because like Avalanche is a good example. As long as you're online and responsive 80% or more, there's no downtime issue, or there's not going to be a loss of rewards or anything else. So I think that's one of the miscommunications people run into a lot with validator performance, is that they'll think uptime has a direct relationship with loss of rewards, and usually it's far less of one than people will expect. The amounts that the network will require you to be online before there's actually a penalty associated are fairly low standards to meet. They're not trying to penalize people for this, especially since, again, this is still experimental technology to a large degree. So how do we measure validator effectiveness on each of these networks? It's specific to the network. How you measure performance on Avalanche is going to be different than Ethereum. It's going to be different than others. So since Ethereum is the one of most interest to people, I'll cover it in a little bit more detail, but just know that there's not a uniform application that specifies high performant validators versus low performant validators across all networks across the industry. We're trying to help develop and work on those standards. We're participating with other validators in the space to do that. But since networks don't have uniform parameters in terms of how they operate consensus, there also really can't be a uniform metric yet for validator performance on those networks. So for Ethereum, there are various measures of performance that you can get from the network itself. Some of these are directly related to revenue. Some of these are related to other aspects that affect revenue. And some, I think, can be a little bit more indicative of high performance than others. So a good example of this is, again, for Ethereum, we have Attestation Effectiveness, which is whenever you are selected to attest to a transaction, did you attest? How quickly did you attest? If the first available slot that your attestation could apply to is made, you're going to receive maximum rewards for that attestation. The slower you were until you just miss the attestation altogether, you're going to earn less and less and less rewards over time. So there's 4 different measures in order for a transaction on Ethereum when you're attesting. Each of those 4 components you can receive a score in. At the end of an epoch, all of your attestations are wound up, and then you receive an aggregate reward for that epoch. If you propose a block, it's either all or nothing. There's no reduction in rewards over time. It's just you receive the reward for proposing, or you failed to propose, so you receive no reward, but there's not a loss associated with it. But the reward for proposing is much, much, much higher than attesting a block. It's about 4 times higher. So if you're covering rank, a validator rank on something like a block explorer, like Beacon Chain, what it is doing is taking all the validators that exist on Ethereum that are in the active set and lining them up based on how much income they've earned over a set period of time, which is usually 7 days on one Beacon scan, for instance, or Beacon Chain. So over that 7-day period, validators can have different types of performance in terms of attestation effectiveness, but the ones that have proposed a lot of blocks will have earned a lot of money, and they will get high scores regardless of whether they're attesting quickly or whether they've attested all the attestations they had, because block proposal pays so much more than attestation of a vote. So we have different rates of rewards that are earned based on the performance that can be done, and being chosen for these things are at random. So on a network like Ethereum, there's a large amount of luck associated with how much you've earned at any given parameter on a week-to-week basis. So for rank, I think personally it's an extremely misleading metric, because you can have the same level of attestation effectiveness over the course of a year, but on a week-by-week basis, your rank will violently change. You could have a set of validators that are in the top 5% because they were selected to propose very frequently compared to the rest of the network that period of time. And then the ones that were chosen less frequently by random chance later will have a lower score, even though their attestation effectiveness was the same during that period of time. So rank, when you see things like rank, it's very important to note, are there very wide discrepancies in how much rewards can be earned over a certain period? And if so, short levels of rank or short time denominations for rank are going to be very misleading. So when we give our validator effectiveness measures, we usually gauge our performance on a week-to-week basis for attestation effectiveness for Ethereum, and rank isn't something we really consider because, again, it's random whether we would have been selected to propose a lot of blocks versus attest a lot of blocks. Since we can't control how often we're picked, we don't think rank is all that relevant. Now, attestation effectiveness, yes, that is within our control, because that's high attestation effectiveness is showing that we are performant and we're up and we're attesting quickly and we're being a good participant in network consensus. Now, income over a period of time is another way that I think is an accurate measure of performance. But again, what type of interval do you be looking here? I think 3-month rolling averages for a network like Ethereum are pretty indicative, because even though there's a chance of being selected more or less frequently as a proposer or as an attester over any period of time, and the odds of being selected as a attester or proposer are going to decrease as the pool of the active set of validators gets larger and larger and larger, the disparities between one validator's performance and another validator's performance based on sheer luck are going to get higher the more participants we have, just because you have less of a chance of being selected the more validators you have. So something like Ethereum right now, 3 months review of how much income validators have earned compared to an average validator on the network is a pretty important metric. But as we get to 1 million validators on the network or 2 million validators on the network, we might be looking at a 6-month time frame or a 1-year time frame in order to be able to truly compare apples to apples. Because again, you don't want to have a lucky validator throw off what true performance means in terms of attestation effectiveness. So it's not just one measure of performance to look at. It's again looking at the right metric over the right period of time. The right metric over the wrong period of time might be extraordinarily misleading, and but taking a look at 3-month rolling averages, 6-month rolling averages, 12-month rolling averages is usually the best way to monitor for these types of attestation effectiveness for a network like Ethereum. Another thing I'll say here too, in terms of validator performance, we're discussing a lot of quantitative metrics right now, but I think qualitative metrics also matter because they're protecting an investment over a longer period of time. So one of the things that I would take a look at if I were looking for a provider for a validator as a service is, what is their relationship like with networks? Do they have direct lines of communication with networks? Do they share a Slack channel? Do they share a Discord channel with that? Are they in communication with them constantly? Do they have a representative for that network that's assigned to them? Do they have people in the company that are networking with those people on a regular basis and communicating with them on a regular basis about what types of configurations to run for clients? Do they need to update or not update their client software based on certain changes? Are we involved in testing any particular changes to the network for them? Are we involved in things like governance? Because all those things will help to protect the underlying value of the network. And as we've seen very obviously here lately, the best networks, the best ecosystems are the ones that are the safest. And in terms of maximizing token value and maximizing the value that you're able to earn on these as you stake, it's also important for the ecosystem to make it. So being a responsible validator and being a high-performant validator in our minds also means being a good community participant, helping to shepherd the community and make sure that all of the validators that are performing well. We don't see validating as a zero-sum game. We don't see ourselves in direct competition with other validators that are in the space in the sense of we have to win by them losing. It's very much a situation that reminds me of a phrase in law school that is pretty indicative, I believe, of how ecosystems work, which is that if you have one attorney in a town, they're going to starve, and if you have 2 attorneys in a town, they'll feast, because you have to be able to have a plaintiff and a defendant, but you can't be both in that situation. And it's the same for validators. Figment can't be the only validator on a network, so we have to have other high-performant validators as well. The more high-performant validators there are in a community and in an ecosystem, the better all of us are going to perform. So we're all relying on each other to a certain degree. So I know I'm near time, but if there's specific questions that any of you have about networks and how Figment views our performance on those networks or how we're managing our scores on those networks, feel free to reach out to me. My email address is nathan@figment.io. And I'd be happy to chat with you all privately about how we see these things and maybe how we can help you monitor for your own performance on separate nodes that you carry on other networks. So thank you very much for your time. And again, if you have any questions, I'd be happy to address them for you either privately or here.
Thanks, Nathan. This was really great. We're going to transition to our next session now. Thanks again.